Okay, right. Right, so chaps, today, shortish lesson. We're gonna learn how to integrate what they call rational fraction. Just to remind you, what is a rational function? It's basically a polynomial divided by a polynomial. Okay, so for example, if I have I don't know, 3x squared plus 5x minus 3 divided by 4x cubed minus 3. Okay, so we've got a polynomial divided by a polynomial. Okay, and we're learning to integrate it. We're not going to integrate everything. Okay, it could be really, really difficult, but we're going to look at some. And we'll start with something like this. Okay, 1 over x times x minus 5. Now, the first stop you might be tempted to do is maybe open it. Let's try that, okay? So we're going to have 1 divided by x squared minus 5x dx. Now, remember last lesson we learned how to integrate 1 over x, okay? If I've got 1 over x, I want to integrate it, the answer is ln x, okay? The natural logarithm of x. But we need plus c obviously, and we need to put the x in absolute values because we can't have a negative values here. We also looked at a situation where we have, instead of the x, we might have f of x, some kind of function at the denominator, okay? And we want to integrate it, okay? Now, we can do that only, and that's going to be important. Now, if at the top, in the numerator, we have the derivative of that function. So if I have the derivative of a function divided by a function, the answer is going to be ln of f of x, absolute values, plus c. Just want to make sure you can see this. Okay, move it a little bit to the right. Here we go. Okay. So this is what we're going to work with. Now, if I'm looking here, you might be hasty and start thinking, okay, isn't that ln x squared minus 5x plus a c? But the answer would be not. Why not? Can you see me when I'm talking? I always do it low. Why is it going to be not? Because what we're missing, okay, we've got a function here, but we are missing the derivative. For this to have worked, we should have here at the top, we have to have the derivative of that, which is 2x minus 5. So if I have 2x minus 5 divided by that, the answer is going to be that. Okay? But that wasn't my original question. So I'll leave that as this. This is definitely right. Okay? If I have a function and here the derivative of that, the answer will be ln of that function. But I'll go back to my original. What happens if I want to integrate that? So even though it looks more simple than that, in reality it's more difficult because I'm missing that derivative of this function. So what we're going to do here, we're going to remind ourselves, okay, how to turn that. Let's leave the integral for a second. Okay, 1 over x times x minus 5. Okay, we want to find out, we want to separate it. Okay, we're going to separate it two fractions. So it's going to be some kind of a divided by x plus a certain b x minus 5. You can see how we can work backward, right? If I gave you something like this, then the common denominator will be x times x minus 5, and then obviously you need to do something with a and b. So what we're trying to do is separate that two fractions that are multiplied by each other to a sum of fractions. Okay? In other words, we need to find a and b. We've done that, if you remember, at the beginning of grade 11. So let's try and do that. The way to do it is, once you've written that, okay, you'll understand that it's going to be a divided by that plus b divided by that. Then we're going to just multiply both sides of the equation by x times x minus 5. What we'll get is 1. Okay, so I'm multiplying both sides of the equation by x times x minus 5. So that's going to be 1. This is going to be a times x minus 5. Okay, because the x kind of kills each other again. Plus b x. Okay, the x minus 5 cancels by x minus 5. Alright, and then I'm going to solve that. 1 equal ax minus 5a plus bx. Rearrange that. Okay, and I'll add the terms with x together. So 1 equal a plus b times x minus 5a. Now, if you first look at this equation, you might say, hang on, let me just see that you can see it. Yeah, you can see it. You might think, hang on, I can't solve that. So I've got too many variables. I've got 1, 2, 3 variables, one equation. How can you solve 3 variables, one equation? But remember, this is, this is a number. Okay? This is a variable. These are parameters. So x can really be any number. So if x can be any number and I don't have x here, then I can write it, if you don't mind. Instead of writing 1, I'm going to write 1 plus 0x. So in other words, what we're doing, we are equating term to term. So if there's no x on this side, 0x is like having no x's, then I must have no x's on this side. So our first equation is 0 equal a plus b. A plus b must be 0, because remember, this equation is true for any x. For any x. So if there's no x on this side, I'll just get rid of it if you don't mind. I don't have x on this side, this must be 0. The second equation is more simple, okay? 1 equal minus 5, okay? Because, 1 equal minus 5a. In other words, I'll write the equation, okay, that's the second equation, and the solution for this obviously is a equal minus a fifth, okay? But now I can look again at this first equation and say, okay, if a minus a fifth, then b should be equal to plus 5, okay? Because together they add up to 0. And now I can rewrite this equation like that, okay? Let me just, again, let's make sure you can see everything here. I'm in Miss Neville's class, so I'm not used to this. So I've got the A and I've got the B. So now I can rewrite this. This is why I'm interested. If A is minus fifth, so instead of A, I'm going to write minus fifth, okay? So it's going to be minus 1 over 5x. If B is a fifth, so I'm going to write 1 here, and I'm going to multiply that by 5. So it'll be 5x minus 25, right? It was, 5x minus 25. Okay? That was really why I'm interested. So now I'm going to just make a little bit of space for me. Maybe I can do that now, straight away, actually. Let's do it straight away, okay? So the whole purpose, if you remember, is going back to this integral. So I'm rewriting this integral as a sum of those two fractions. So it's the integral of 1 or minus, there's a minus 1 over 5x plus 1 over 5x minus 25, all of that dx. Okay? Now I'm going to pause and make some space. Okay, so once we, there's really 2 stages to this question. And that's why these questions are actually quite popular. I notice them in a lot of exam papers. The first stage is just to separate this fraction into a sum of 2 fractions. And now we're just going to integrate it. Okay, we've done it a million times. Okay, the integral of the sum is simply the sum of the integral. So I'm going to do the integral of 1 over 5x dx. And check out what I'm going to do. I'm going to put the minus. There. So I could put the minus here, but timing by constant, I can always take it out with an integral. Plus the integral of 5x minus 25. Okay? In fact, if you don't mind, what I'm going to do here, okay, actually 5x minus 25, okay, I could have kept it, it was 5 times x minus 5, I could have kept it like that. And then, trying to get you used to, if you've got a constant, I mean, what is 1 over 5 times x minus 5? It's basically 1 over x minus 5 times fifth. So again, I can take that out. It's actually worthwhile doing that a lot of the time. It makes your integration much easier. If you ever have a function which you just is multiplied by a constant, get it out of the integral. It's not doing anything there. Same thing here, right? I've got the minus 1. Might as well get out the whole minus 1 over 5. Okay? Now, these are dead easy integral to calculate. So first of all, I'm going to write 1 or minus 1 over 5. The integral of 1 over x is very naturally ln of x. plus 1 over 5. Okay, integral of 1 over x minus 5 is simply ln x minus 5. Okay, so that's about that. In fact, we can do something further, just to make it pretty. I can take 1 over 5 as a common factor, and then I'll do ln x minus 5 minus ln x. Okay? And then I can do even something further. If you remember logarithm rules, okay, I can take the 1 over 5, keep them out there, and then do, what is ln? Logarithm minus a logarithm in the same case is basically the logarithm of that divided by that. But I still must keep the absolute value. Okay? I can do one more thing, but let's just leave it. This is probably the easiest, the nicest expression for it. I'll pause here. We'll do one more difficult question. Okay, obviously, I did forget one thing. Olivia's not here to remind me. We must add a constant. Okay, I'll pause and we'll move on. Okay, so there was really only one example in the book, but I really thought about it, and I said I'll solve one more example because it's actually a good place for us to revise this whole idea of rational function. How do we separate a polynomial into a sum of different, a rational function into a sum of rational function, okay? So the first part, we just need to separate this ugly monster into a fraction plus a fraction plus a fraction. In this case, it will be 3. And then we just do the integration, which actually works out the easy part. Okay, so yeah, what's the business with this? Okay, I'm going to leave some space. Hopefully that will be enough space. So I'm going to write down what we need to find out is 15 minus 13x plus 4x divided by 1 minus x squared, 4 minus x. We want to separate it. Now, this monster is going to be made out of 3 different fractions. The first one is going to simply be a divided by 1 minus x. The second one, if you remember, what we've got here is a repeating. We've got a square. Okay? So it's going to be made out of two fractions. Okay? One where it's not squared and one that it is squared. Why is that? Because if you think about it, let's get rid of it. Let's say we didn't have him. What will be the lowest common denominator like 1 minus x squared? Well, you might think it's just 1 minus x squared. But hang on, if we also add that fraction where it's 1 minus x, those two together will have a common denominator of 1 minus x squared. So you see, it's those two. You need to find the a and a b. And plus, we obviously have another c divided by 4 minus x. That's it. Okay? I'll just pause to make sure you guys can see it. Okay, so now I just want to see where I can write down maximum exactly here. Let's see this little border. Yeah, cool. So I'm going to start solving that. Should have already used all this space. If I multiply by this whole thing here, what I'm going to get is 15 minus 13x plus 4x squared. By the way, sorry, that should have been x squared. I'm checking the textbook here, it's 4x squared. Should be equal to a. What should we multiply a by? To sit on top of this, you need to multiply by 1 minus x times 4 minus x. Okay? Plus b. b sits already on 1 minus x squared, so we need to multiply by 4 minus x. c. We need to multiply by 1 minus x squared. Okay? So we've got one equation here, but actually by comparing term by term, we'll be able to find, hopefully, a, b, and c. Okay, let's write it down. Hopefully you guys can see it. Right, so rewrite this 15 minus 13x plus 4x squared equal a. Let's do that first of all. Okay, it's going to be minus x minus 4x plus x squared plus b. Very skewed here. So b times 4, 4b minus bx. And then this is c plus c minus cx squared. Okay, writing again, 15 minus 13x plus 4x squared equal, okay, this is minus 5b. I'm hoping I'm not making a mistake here. So it's minus 5x. So it's going to be minus 5ax plus ax squared. And then here, this is going to be, all right, plus 4b plus c minus bx minus cx squared. I think what I'm going to do, just so I'm not going too low, I'm going to rewrite the whole thing, but I'll compare term to term. So let's start with the numbers. 15 must be equal to all the pure numbers here, which is 4b plus c, that's it. 15 equal to 4b plus c. Great. Let's look at the x's. Minus 13x, okay, will be equal to minus 5ax minus bx. Yeah? So minus 5a, and I'll take, okay, minus bx. Minus 5x minus bx. If you don't mind, I'll pull x out as a common factor. Okay, so put in there. And what we're going to have is minus 5a minus b. Minus 5a minus b. Right? Minus 5a minus b. Okay. X squared. 4x squared, this one, that should be equal to ax squared minus cx squared. In other words, I'll do it straight away if you don't mind. It's a minus c x squared. So we've got three equations for three variables. And I think at this point of time, okay, I'm going to just tidy up them a little bit. Okay, I can divide by x squared because x can be anything. So I've got 4 equal a minus c. I'll divide by x, this one, so it will be minus 13 equal minus 5a plus b, making it times by minus 1, so it's 13 equal 5a plus b, and that's it, okay? Now, if you don't mind, yeah, we'll call this one equation 1, 2, and 3. I personally like elimination, okay? So if I'm adding 1 plus 3, I'm going to get 19. I'm going to eliminate this, but then I've got 5, so that's not going to help me. Okay, let's forget about elimination. Let's forget elimination, and we'll do substitution, okay? So I'm going to write from 3, I'm going to say that a equal 4 plus c, okay? And then I can substitute, for example, here. I'll put that into 2. So 13 equal 5a, so it's 20 plus 5c, right? I just multiply it by 5, and plus b. Okay, so I'm going to rewrite that, move the 20 over there, so I'm going to write 5c plus b, okay, equal minus 7, okay. Now if I'm looking at those two, you know, I can do some elimination, but I'll carry on the substitution. So I'm going to write b equal minus 7 minus 5c. Oh, it's a long question. Now I express b in terms of c, can feed it into here, okay. So I'm going to write that again, 15 equal 4. Instead of b, I'm going to write minus 7 minus 5c plus c, that's it. 15 equal minus 28 minus 20, I'm sure I've done a million mistakes there, minus 20c plus c. Okay, so I've got minus 19c, and I move the 28 to the other side. 42, I'm sure I made a mistake, guys. Okay, c equal minus 42 over 19, and we got the first one. Okay, now once I've got the c, I should be able to get the b. So b is going to be equal to minus 7 minus 5 times c. Okay, you can see I'm 100% made a mistake because the number here are terrible. Okay. And once I find the b, okay, we're going to use a calculator for that one. sure I made a mistake. 9 times 42 divided by 19. Yeah, no, I think guys we can leave it there, because I probably did a mistake there. Maybe your homework will be fine with where I made the mistake. But once hopefully you find a mistake, you'll know what the real C is, what the real B. Obviously then you will use this equation to find what A is. And once you find A, B, and C, you can rewrite this integral as A divided by 1 minus x plus the integral of B divided by 1 minus x squared plus C divided by 4 minus x. And that will be the easy one. Okay? That will be easy one. Except that this is going to be a problem. All right. Okay. Let's actually discuss that. I'm going to make some space. Yeah, sorry about that. I don't think I decided to stop with this because these numbers are looking ridiculous, and hopefully you can find the mistake here. Or maybe not. Maybe the number is supposed to be ugly. But I want to discuss this one because here we're going to have an issue. Okay, let's pause. Okay, I felt a little bit guilty, so I just paused, and I did find actually at least one mistake. Okay, so let's try and work it out. Okay, there's definitely a mistake here. Okay, when I simplified that, I forgot 1 times 4. Okay, so I did minus x minus 4x plus x squared, but the first term really should be 1 times 4, which is 4. Okay, so let's just check that the rest, I'll pause and check again that there's no other mistakes. Okay, I did go through it now, and well, not all the way through, but enough to get a feeling that, okay, now we're going to get it right. So, yeah, the only difference was that I forgot that 4. 1 times 4 is 4, so I've got also an extra term here, 4a. And actually, by introducing that, it seems to be working well. So I'm going to just compare against terms. So the free number 15 is equal to 4a now. Also have 4a plus 4b plus c. Then let me write straight away the terms with x. I'll get rid of the x straight away. So whatever in front of the x on both sides have to be the same. So minus 13 will be equal to minus 5a minus b. Okay, so these are all the things that are in front of the x. And straight away, as I did before, I can just turn that to positive. Okay? And then the last equation for the x squared, this is the same. Okay? And the third one is also the same. The x squares also have to be the same. So 4 equal to a minus c. Okay? So these two equations, right, is that extra 4a here that makes all the difference. And now I looked at it, and here elimination is very good. Okay? So the first, second, and third. Okay? And what I'm going to do, I'm going to add these two. Add these two. Add these two. What happens when I'm adding 1 plus 3? I really like elimination. I don't know about you. When you add them, you're going to get 19 equal 4a plus a is 5a plus 4b, and the c eliminates itself. Okay, they kill each other. Now you might say, hang on, I'm still with two variables here, but when I'm adding them and comparing it to 2, they have the same terms in a. So when I'm going to do that minus that, I get rid of the a completely. So I'm going to do this equation that I just had, and I'm going to minus 2, equation 2, I'm going to get 19 minus 13 is 6, 5a times 5a kill each other, 4b minus b, 3b, and that gives you a nice little b equal 2, which is much nicer, okay? Right, now when I know b, I can just feed it in here and I guess get a. So therefore, I'm going to put it there, 13 equal 5a plus 2. That means that 5a equal 11. Okay, I'm getting a little bit not so nice now, but it's still all right. Meaning a equal 11 over 5. Hopefully that's all right. Okay, now let's find out c. Okay, so I guess I can use this one to find c. So if I've got 4 equal a, 11 over 5, minus c, okay, not looking as pretty, but not as bad as before, that's 11 over 5 minus 4. Okay, and maybe we'll just write 4 as 20 over 5. So the answer is minus 9 over 5. Yeah? I'm hoping. Okay? It's looking not as bad as before. So I've got that, and I've got that. I've got all the A, B's, and the C's. Now, what's the idea? Okay, I can actually use what I've arranged here. Okay? So, you know, if it's a sum of these three fractions, I can just put them in the integral there. So A, we said, is 11 over 5. So I'll write that as 11 over 5. Okay? B is the pretty one. B was the only sensible one. Is 2 over. Okay, that's going to be good. That's going to be good. I might have a problem there. Okay. And C is minus 9 over 5. Okay, minus 9. I'll put the 5 over here. Okay, I need to make some space. Okay, so the next stop, as I just told you in the other exercise, I've got a bunch of constants times some kind of fraction with x. And as I told you before, it's much easier. Get them out. So this integral, okay, it can be 11 divided by 5 times, obviously I should have all the dx's here, okay? I'll get the 11 over 5 out. So it's going to be 11 over 5, 1 divided by, 1 minus x dx. See, I just got the 11 over 5. Here, okay, I'm going to get the 2 out, and the integral of 1 over 1 minus x squared dx. And the last one, I've got the minus 9 over 5, so minus 9 over 5, integral of 1 over 4 minus x. See, I've got that 5 out. Okay? 1 over 4 minus x dx. Now, with your permission, to solve that, I'm going to start with the first and the third one. They're the easy ones. Okay? So 11 over 5, what's the integral of 1 divided by 1 minus x? Well, it's going to be something with a logarithm of 1 minus x. But don't forget that we need to multiply it by the derivative. So what am I saying? If I just left it like that, let's leave the constant, so 1 minus x, if I do a derivative of that, what am I going to get? I'm going to get the 1 minus x, which is what I want it to be, but I also need to multiply by the derivative of 1 minus x, which is 1. Okay? Let me just pause that little phone call.